In today's video, we will continue looking at methods of examining and summarizing numerical variables or data. We will continue to focus on looking at numerical data from a one-dimensional point of view, with an emphasis on the graphical method known as a box plot. Recall that previously we looked at the following key numerical summary values for a one-dimensional view of numerical data. First, we talked about the measure of center, known as the median. Secondly, we talked about two measures of position, namely the first and third quartiles. Thirdly, we talked about measures of variability or spread, namely the interquartile range, which is equal to Q3 minus Q1, and the range, which is equal to the maximum minus the minimum. The so-called five-number summary incorporates all of the above measures. All right, now let's take a look at box plots. Box plots are constructed based on the five-number summary. Rather than showing how to construct a box plot by hand, I will use our guru to construct a box plot for the Loan 50 dataset's interest rate variable. We will then discuss box plot components using the interest rate box plot as an example. So to create a box plot for the interest rate variable of the Loan 50 dataset, we begin by going to Plots. I left-click on that menu item. I left-click on Create Plot. I then left-click on Box Plot. The dataset that we're interested in is the Loan 50 dataset, so I left-click on that. I then come down to the interest rate variable, and I double left-click on that one, which then will put it in the selected variable box area. I want this to be a horizontal box plot. You can the default is typically a vertical box plot otherwise, and let's take a look at what it looks like. So we do a preview of it, and there it is. There's the box plot. Now, I don't happen to like the way that looks. I want it to fill my screen a little better, so I'm going to go to the details. I'm going to go to the image and the plot. I'm going to select the image type to be a JPEG, a picture instead. I'm going to make the width of it 1,000 pixels. And I'm going to make the height 300 pixels, and let's see what that looks like. And let's go ahead now and do a preview. And that's maybe a little bit too long, so I'm going to make the details and change this to only 800 pixels wide. And now I can see the whole image on my computer screen. And that's all there is to forming a box plot. So let's take a moment to talk about the components of a box plot. The first component, the line that is inside of the box, the vertical line inside of the box, is the location of the median. For the example that we've been doing, which is the interest rate variable of the Loan 50 dataset, that value is at approximately 10%. The left of the box, the vertical line marking the boundary of the leftmost part of the box, is the first quartile. Notice that corresponds in this case to approximately 8% on the interest rate axis. And then the rightmost boundary of the box is the third quartile value, and notice that that's at approximately 14%. Now, to the left of the box, we draw what is known as a whisker, and the leftmost edge of the whisker in this case corresponds to the minimum value. The rightmost whisker, which is on this part of the box plot, you'll notice that it doesn't go quite all the way to these other data values that are to the right of that. So the rightmost value, of course, is the maximum data value, which we saw was larger than 26%. Notice that I have marked on the box plot the five-number summary values. Now we're going to take a moment to talk a little bit about the construction of the whiskers and explain a little bit about the dots that are to the right of the rightmost whisker, which is located here. That's the rightmost whisker. We need to figure out what value that is and how to find it. And then these dots that are to the right of that rightmost whisker, which are called outliers. All right, I want to take a little bit of time now to talk about how the rest of a box plot is constructed, specifically the left whisker, which is this part on the left to the box, and the right whisker, which is the part that I've drawn to the right of the box. And then I also want to talk about how we identify these dots, which correspond to data values that we call outliers. So the first step in doing this is we're going to calculate what is known as the leftmost fence. And so I've gone ahead and shown that this blue vertical line corresponds to what we call a fence. The value is found by taking the first quartile minus 1.5 times the interquartile range. And when I calculate that value, that corresponds to approximately -1%, which of course doesn't correspond to any data values in our data set. Now I'm going to do the same thing on the right-hand side by taking the third quartile and adding 1.5 times the interquartile range to that. I get what is another fence, that's the rightmost fence, and that's going to be a boundary for our data values that separate the data set that are the data set values that are what we might call normal versus those that we call extreme or outliers. Now that value calculates to approximately 23%. So anything between these two fences in the data set would be considered normal data values. Anything outside of the fences to the right of the rightmost fence would be outliers, and that's why we show those with dots in this case. And anything to the left of the leftmost fence would also be considered outliers, but in this case we don't have any data values to the left. Now let's focus on the leftmost whisker here. Notice that I stopped this whisker at a value of about 5.5%, corresponding to the data value that is the smallest, the minimum in this case, and that's why our whisker stops short of this leftmost fence, because there are no data values between this whisker and the fence at the left. Same thing's happening at the right. The reason the rightmost whisker doesn't go all the way to the fence is because there's no data value at 23%. In fact, the most extreme data value before getting to the fence at the right is this data value at about 21.5%. And then, of course, these two values, the outliers, are two data values that are outside of the rightmost fence. And that's it. That's everything behind how we construct the left whisker, the right whisker, and these outliers by using these fence values as our means of doing so.